what is the parent function? Mm-hmm. So if you change that to exponential, it means 1/2 to the y power equals x. So if we're making our t-chart with our 3 points, the y is the exponent. 1/2 to the -1 is 2. 1/2 to the 0, and 1/2 to the first. So if I plot this, 2, -1, 1, 0, 1/2 1. You know, log has a vertical asymptote. Then what's the transformation this time? How is it going to move? Left 3, down. So if I take each of these points left and down. Where's my vertical asymptote end up? At -3. So we do need to make sure we draw that in. And it looks something like that. Why was this one decreasing? How could we know that from the original? Yeah, because the base was smaller than 1. Alright, let's look at this one. If I ask you to solve it, what are your thoughts?
2 to the length gives you 6 and 16. I mean, 1/2 to the length gives you 16.
Okay, so you changed it to exponential. What'd you do with this square root?
I left out for later.
Left it for later. So there's different options. A square root is the same as a 1/2 power, so you could write this as 1/16 to the 1/2. Or you could have squared each side at the beginning to get rid of it. Which route do you guys want to take? Huh? Square it? Okay, so if we go that route, we x squared equals log base 1/2 of 1/16. Okay, so that means 1/2 to the x squared power equals 1/16. What do we have to get here to solve these exponentials? What do we have to have?
Base.
Common base. So 1/16, that would be 1/2 to what power?
The 4th.
4. So if we do that, we get x squared equals 4, which means x is plus or minus 2. Okay, but we always check these. Are both options possible? Why? Okay. If I do
Oh
a
wait.
well,
Yes.
so in a log, the argument and the base have to be positive, which they are. It can equal negative. However, this one is equal to a square root. When you do the square root of something, what kind of number do you get? A positive. So because of that square root on the original, that's why it has to just equal a positive 2.
Wouldn't it also be because if one's positive, the other has to be positive if they're both fractions like
Yes.
this?
Alright, expand these. So break apart the logs. So we write the log with each one. The square root of x, so that would be, and where do we put the 1/2? Alright, times, so that means it would get a
Plus
log base 3. The key root of y would be y to the 1/3, so the 1/3 comes in front. Divided by means minus 2 log base 3 of w. This one is also on the bottom, so it's another minus, and that would be a 1/2 log base 3 of z. Is that one okay? Alright, this one, if we break it apart, we get log base 5 of 5 plus log base 5 of the square root of 7, so that would put a 1/2 in front, minus log base 5 of 3. What else could we do?
You could give the log base 5 of 5.
Log base 5 of 5 says 5 to what power equals 5? And that's a 1. So that's our simplified answer. Is that okay? Let's look at this one. If I'm asking you to condense a log, that means we have to put it back together. This 2 would turn into an exponent, so that would be a z plus 1 squared. Minus means divide by the 3z plus 2. Minus means that would go on the bottom. A 1/2 would be what? Square root of 16. What is the square root of 16? Just the positive. Because it doesn't have a plus or minus in front. And that would be our final answer. Alright, that's fine. If I want the domain, what do we have to do? Square minus 9 has to be, what'd you say? Greater than or equal to 0. Alright, this is a quadratic that factors into x plus 3x minus 3. How did we figure it out from here?
Sine thing.
So x plus 3 equals 0 being negative 3, x minus 3 equals 0 is at positive 3. Then we did test points. Smaller than negative 3, in between the 2 and bigger than 3. And we're putting them in to see if we get a positive or a negative. So if I put in a negative 4, I get a negative times a negative, which is positive. If I put in a 0, I have a positive times a negative, which is negative. Put in 4, positive times positive is positive. Which ones do we want?
That's
Negative infinity to negative 3, because it's equal to, that gets a bracket. Negative